Hello, my name is Bikram Chatterjee, and today I want to talk about something that could potentially be the biggest cybersecurity threat of the next decade. We're talking about deepfakes. Now, before we delve into this topic, I want to shift our focus to big data. As you might already know, we live in a time where data has become the most valuable currency in the world. Every single day, many of us expose more and more of our personal data online, and as a result, many multi-billion dollar or now even trillion dollar conglomerates such as Facebook and Google collect and analyze this set data in an exorbitant amount of detail to generate ad revenue. Now, some of us may not care about their data getting used for targeted ads, but what happens when the same data, which we should own and control, is used against us? I mean, in recent years, this has happened a lot of times already. In fact, if you ask people what is currently wrong in the tech industry today, you might get an answer about Google's latest data leak, fake news, or even something about data companies constructing our psychological profiles and using it to manipulate our behavior to influence election results. Hence, it is clear that the current situation regarding data privacy in the tech industry is already as bad as it gets. However, when the world learned about deepfakes in 2017, we realized that our data could now be weaponized against us in ways that could completely destroy our lives. So that brings us to our main question. What are deepfakes? So deepfakes represent synthetic or fabricated media, such as videos or audio recordings, that are generated by manipulating images, videos, and voices of real people using an artificial intelligence or AI technique called machine learning. Now, I know that although some of you may have heard of these terms before, you guys might not exactly be familiar with them. So, let me give you a quick overview of what is machine learning. So, machine learning basically focuses on the development of computer programs that can access data and use it to learn for themselves. The process of learning actually begins with observations or data, such as examples, a direct experience, or instruction, in order to look for patterns and make better decisions in the future based on the examples that we provide. The primary aim of machine learning is basically to allow computers to learn automatically without any kind of human intervention or assistance. As a rule of thumb, the more quality of data you provide, the more accurate a machine learning algorithm becomes at performing its tasks. Now, you might wonder how machine learning is relevant in creating deepfakes. Well, the word deep in deepfake actually comes from deep neural networks, or what we commonly know as deep learning. So, deep learning is actually a subset of machine learning, or in other words, it is basically an ML algorithm which tends to replicate the function of the human brain and thereby allows it to think and make decisions like humans. Now, while classic machine learning algorithms solve many problems that rule based algorithms struggle with, they are actually poor at dealing with soft data such as images, videos, sound files, and unstructured text. This is the primary reason why deep learning is actually the main technology behind many of the applications that we use every day, including online language translation and automated face tagging in social media. So, deep learning is able to achieve this with the help of something called neural networks, which are present in the heart of deep learning algorithms. Their name and structure are actually inspired by the human brain, which mimics the way that biological neurons signal to one another. Neural networks contain layers upon layers of variables that adjust themselves to the properties of the data that they're trained on, and then they become capable of doing tasks such as classifying images or converting speech to text. Now, these layers, which are specifically known as node layers, contain an input layer in which we feed in our data set, containing thousands of pictures of the type of the data that we want our algorithm to identify. There are also one or more interior layers in the middle, which are sometimes also called hidden layers because they are not directly observable from the system inputs and outputs. And lastly, there's also an output layer that produces the output variables. Now, each node or artificial neuron connects to one another, and has an associated weight and threshold. If the output of any individual node is above the threshold value, that node is activated and it sends data to the next layer of the network. Otherwise, no data is passed along to the next layer. So, neural networks are actually good at independently finding common patterns in unstructured data. Through pattern recognition, our model can actually detect different categories and get information about some particular data. For example, when you train a deep neural network on images of different objects, it finds ways to extract specific features from those images, such as faces, eyeballs, chin, color, etc., and then finally generate an output. With deep learning methodologies, a deepfake creator can seamlessly stitch virtually anyone in the world into a video or photo that they never actually participated in and portray them to be doing things that they never did or saying things that they never said. To better understand the gravity of our current situation, let's take a look at this video of President Obama.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, uh, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or how about this? Simply, President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele.
Now, deepfakes have actually been around for a long time, but they first became popular in 2017 after crudely produced videos began to surface on the internet, which typically involved celebrity face swapping or manipulation. So the deepfake video that we just saw is just one of thousands of videos that have been uploaded online. In fact, according to DeepTrace Lab, which is a deepfake detection technology firm, as of June 2020, deepfake videos identified online doubled to almost 49,000 in just 6 months since January. Hence, it is no surprise that according to various security experts, deepfakes currently pose the biggest threat to privacy, democracy, and security, as deepfake methods can be employed to create videos of world leaders and celebrities with fake speeches or actions for falsification purposes. As a result, deepfake technology can be abused to easily mislead the general public. For instance, in March 2019, the Wall Street Journal reported that some scammers used deepfake software to impersonate the chief executive's voice and demand a fraudulent transfer of $243,000 to the bank account of a Hungarian supplier. Deepfakes also have the potential to cause political or religious tensions between countries, or even spread disinformation to affect election results or create chaos in financial markets. Furthermore, deepfakes can even be used to generate fake satellite images of the Earth, showing objects that do not really exist to confuse military analysts. For example, creating a fake bridge across a river, although there is no such bridge in reality, this can mislead a troop who have been guided to cross the bridge in the battle. Now, deepfakes also offer a light-hearted upside. For instance, we know that visual storytelling is an expensive business. Hollywood studios spend billions on creating spectacles that wows their audience or transports them to another world. However, the tools that creators use to close the gap between what they can imagine and what they can create remain prohibitively expensive for most creators. With deepfake technology, creators can now incorporate the ability to synthesize imagery, potentially giving smaller scale creators a similar capacity for bringing imaginative creativity to life. Deepfakes can also help create voices of those who have lost theirs. Furthermore, suppose that you're an artist who has a good voice and talent. You can potentially take your career global by using your voice manipulation in different languages. AI startups like Synthesia have already shown such applications in 2019 when they used deepfake technology on David Beckham's face and voice and showcased him to be speaking out about anti-malaria in 9 different languages. Deepfakes also have a considerable amount of potential in the art and history world. Last year, researchers at Samsung's AI lab in Moscow were able to transform Da Vinci's famed Mona Lisa into video, which used deep learning to show the subject of the painting moving her eyes, head, and mouth. Likewise, in May 2019, the Dali Museum in St. Petersburg, Florida, used deepfake technology as a part of the new exhibition. They actually managed to display a life-size deepfake of Dali that had been created after almost 1,000 hours of machine learning of the artist's old interviews. So now that we have soaked in all this, let me give you a quick overview of how we can go from zero to creating our own deepfake. Currently, two projects dominate open source deepfake generation, namely FaceSwap and Deepface Lab. Although there are some differences between the two in terms of documentation and features, the primary steps of generating the deepfake remain the same. Now, for the purposes of this presentation, let's go with FaceSwap. The FaceSwap workflow consists of three basic steps. The first step in deepfake creation is to extract the frames containing the faces from the source and destination videos. You're looking for several hundred to a couple thousand high quality images at the end. Your model is only going to be as good as the data as it learns from, so if you want good output, you also need good input. This means going through thousands of images to make sure that they're high quality and that face swap detected the faces properly. The next step involves training your data. So after extracting the images, you can use them to train a deep fake neural network, like the one that we discussed before. So the neural network should be able to take in an image of one person's face and then output an image of the second person's face with the same pose, expression, and illumination. Lastly, we need to apply the model trained in the last step to a specific video, producing a deepfake. Once the model is trained, it can be applied to any video containing the specific people it was trained on. These three steps require radically different amounts of human and computer time. The extraction software runs in a few minutes, but then it can take hours of human labor to check the results. The software flags every face in every extracted image, as well as a fair number of false positives. To get the best results, we need to go through the data and delete irrelevant faces, as well as anything that the software mistook for a face. At the core of face swap is a variational autoencoder or VAE. To make a deepfake video using VAEs, a creator first runs a facial recognition algorithm on a dataset that contains pictures of both the targets. Next, VAEs are trained to find and learn similarities between the real and fake faces and then isolate them to the shared common features. As the VAE processes more and more data, it eventually gets better at generating new flawless results with time. A second AI algorithm called the decoder is then taught to recover the faces from the compressed images. Since the faces are different, the creator trains one decoder to recover the first person's face and then another decoder to recover the second person's face. Finally, to perform the face swap, the creator simply feeds the encoded images into the wrong decoder. As of today, new technology is making the process of creating deepfake videos easier, such that any user can create a deepfake with only a few taps on their smartphone. So, what can we do about it? Interestingly enough, using AI is one of the most promising solutions, because the alternative would be to have a team of human researchers scan millions of videos and sites to detect the fakes. With technology increasingly becoming readily accessible by the general public, more and more researchers are focusing on deepfake detection algorithms that can mitigate AI generated disinformation. However, experts state that such algorithms will only ever provide a partial fix to this problem, as there are much bigger factors at play that might make regulating unreality a thing of the past. That's it. Thank you for watching.